This is Chapter 2, Psychological Research. In this chapter, we'll be talking about all of the different methods and types of research that we use in the field of psychology. We'll be talking about the scientific method, as well as the advantages and disadvantages of all of these different types of research.
Again, here's our same definition we used last week. Psychology is the scientific study of behavior and mental processes. Just like we talked about last week, we're going to break down that definition just to give you a little bit of a reminder as we talk about the science of psychology. Here are our definitions again. Science, using systematic methods to observe, describe, predict, and explain behavior. As I said last week, psychology being a science is more about how you study, not as much what you study. Just like chemistry or biology or physics, we use the same systematic, organized methods in the way that we conduct research in psychology. What we study are the behavior and the mental processes. So this week we're talking all about these research methods and how we use them in the science of psychology. Just like all of those other hard sciences, in the social science of psychology, we also use the scientific method. Now, probably in every single science class you've ever taken, you talk about the scientific method, you talk about the steps of the scientific method. It's always frustrating to me as a professor that every textbook we have has a different definition for the scientific method. It has different steps of the scientific method. So it's important that you read your textbook and you understand what your textbook considers the definition and those steps for the scientific method. We say it is a systematic procedure of observing and measuring phenomena, the observable things, to answer questions about what happens, when it happens, what causes it, and why. It's an interaction between theories, hypotheses, and research methods. Psychologists always should follow carefully planned systematic steps so that we're all conducting research in the same exact way. We want to be objective and not let our own thoughts or theories interfere with that research. And we want to create scientific methods in our research so that people can replicate or reproduce our studies to see if they can get the same findings that we got, or maybe they'll get different findings if they change different variables in that. So that's why it's very, very important that we have that systematic procedure, the organized way of how we conduct research.
Before we talk about the steps of the scientific method as we use them in psychology, it's important to talk a little bit about the process of our research in psychology in regards to inductive versus deductive reasoning. Deductive reasoning are where the results are predicted based on a general premise. So you know one thing to be true. For example, all living things require energy to survive. That's your premise. Ducks are living things, therefore ducks require energy to survive. That's your conclusion. So you have a premise, and based on that deductive reasoning, you have a conclusion. In psychology, we also use inductive reasoning, where we draw conclusions based on our own observations. And we're going to be talking a little bit about observational research as well. For example, you see a fruit growing on trees in a lot of different places, a lot of different types of trees, a lot of different types of fruits, and therefore you assume that all fruit grows on trees. So scientists form ideas through deductive reasoning. The hypotheses are then tested through empirical observations, and scientists form conclusions through inductive reasoning. These conclusions lead to new theories and new hypotheses. This is really the basis for the scientific method. So now let's talk about those steps of the scientific method. Now let's talk about the steps of the scientific method. Now these steps might be a little bit different from the steps of the scientific method that you've learned in other classes or from other textbooks, but these are the ones that we're going to use from this class. Number 1, formulate a theory. We're going to talk about what that is in just a second. Number 2, develop a testable hypothesis. Number 3, test with a research method. Number 4, analyze that data that you have collected. And then finally, number 5, share the results and conduct more research.
A theory is a model of interconnected ideas or concepts that explains what is being observed and makes predictions about future events. To me, a theory is a big picture. It's something that you notice in your everyday life. It's very broad, it's very general. Number two, though, the hypothesis is very specific. It's your specific prediction of what should be observed and if a theory is correct. So if my theory is correct, then I should observe my hypothesis itself. And then number three, we want to test that hypothesis. And in testing the hypothesis, we have to use one of three main types of research, either descriptive, correlational, or experimental. And we're going to talk about all three of those today. Before we're going to analyze the data, we have to see whether or not that hypothesis is supported. We're going to use descriptive statistics. We have a lot of raw data coming in from our research, and we want to be able to analyze it to tell us what those numbers mean. And then we're going to report those results that we have so that other people can look at our research and determine if it's accurate or not, or try to maybe replicate it as well. Here are the three main types of research methods that we're going to cover. We're going to talk a little bit about descriptive research, correlational research, and experimental research. Some of these are very straightforward, and some are a little bit confusing. So please, if you have questions after reading your textbook and listening to this PowerPoint, again, please don't hesitate to contact me, and I'm happy to meet with you on Teams and explain it in a little bit more detail if you need me to. Let's talk about these methods. Here we've broken them down. Descriptive methods describe what is occurring, and we're going to talk about three different categories of those: observational, self-reports, and case studies. Then we'll talk about correlational methods, where we look at relationships between variables. And then finally, we're going to look at the experimental methods when we're talking about cause and effect. Okay, our first type of research is descriptive research, a research method that provides a systematic and objective description of what is occurring. There are many different types of descriptive research. We're going to talk about observations first, both laboratory and naturalistic observations. We're going to talk a little bit about surveys and interviews, and then finally we will end with the case study. These observational studies are a specific type of descriptive method involving systematically assessing and coding observable behavior. There are both advantages and disadvantages of this, depending on what you're studying. We look at laboratory observations as well as natural observations. A laboratory observation is where you actually have people come into a psychological laboratory. They know that they're being studied. Let's give an example of, let's say we want to research young mothers and how they discipline their children, okay? And we put up flyers all around the community in grocery stores and libraries and preschools, and we invite mothers to come in to our research study so that we can study how young mothers discipline their children. And we say, okay, young mothers, you have to be between the ages of 20 and 30. Young children or toddlers, we're going to say they're going to be between the ages of 3 and 5. We put these flyers everywhere, and we say, if you come in and do our research study, we will give you a $100 Visa gift card. So the moms line up on the regular day, they come into our laboratory, we give everybody who is the right age and has children the right age maybe this $100 Visa gift card. Maybe we have Starbucks out for them, we have pastries, we have lots of great toys for the kids to play with, comfy couches for the moms to sit in. And then, just like a lot of laboratories in psychology, there's that infamous double-sided mirror, right? Where we're all on the other side of the mirror watching these young mothers and how they discipline their children. That's a laboratory observation. Now, there are advantages and disadvantages to this Of course, a big advantage is that you have a lot of control. You're controlling exactly who is coming. You're controlling how old the children are. You're controlling the environment, that it's a nice comfy room. You're giving them snacks and coffee. There are great toys for the kids to play with, right? You have a lot of control. The biggest disadvantage of laboratory observation is that the people know that you're watching them. You know, people watch TV, they watch movies, they know what that double-sided mirror looks like, so that when something happens, and let's say a little kid does take a truck from another little kid and he beats the little kid over the head with it, what do you think that mother's going to do? Her natural reaction might be to reprimand him, but she knows she's being watched. So she might say, you know, hey buddy, that you know that we have to share and we have to be a good boy and we have to let everybody play with the toys, right? So the biggest disadvantage is that people know that you're watching them and they might not behave as though they naturally or they usually would. Our second type of descriptive research is a naturalistic observation. This is where we're going out into our environment without any kind of disturbance and we're just watching what happens naturally. Let's say that also in this study of how mothers discipline their children, I have the class maybe visit 2 or 3 different parks in the area, and they go out to the parks and they sit on a bench and they just watch. And they take notes. They don't tell anybody what they're doing. They're just sitting there taking notes. And they say that maybe they see that same young mother who was in the laboratory observation, and now her little kid is hitting some kid over the head with a truck, right? Maybe she yells at the kid. Maybe she hits him over the head with a truck. Maybe she takes him and leaves. Maybe she puts him in timeout. Whatever. The biggest advantage of naturalistic observation is that people act as though they normally would because they don't even know that you're watching them, right? So you're going to get the real behavior. The biggest disadvantage of naturalistic observation is that you have no control. What about if I give you this project and on the day you're supposed to go watch these kids in the park, it's a horrible thunderstorm and there's nobody there? Or what if you go and there are no little kids there, there are only teenagers hanging around the park, right? You don't have control. So make sure you know this for your exam, the disadvantages and advantages of both laboratory observation and naturalistic observation. Laboratory observation, biggest advantage, lots of control. Biggest disadvantage, people don't act as though they normally would because they know you're watching. Naturalistic observation, biggest advantage, people act as though they normally would because they don't know that you're watching. Biggest disadvantage of naturalistic observation, you have no control. So it's the opposite of one to the other. Now, which one do we use? Well, it absolutely depends upon the situation. It depends on what you're studying that's going to give you the best results. The next type of descriptive methods are the self-reports. Self-reports are a descriptive method that consists of obtaining self-reports from research participants. Sometimes we use questionnaires, surveys. We can do it in a lot of different ways, in person, over the phone, sending an email, or doing something online. It's a really good way for us to get a lot of data from a lot of people. It's very quick, it's very inexpensive as well. The last type of descriptive research that we're going to talk about is the case study. We use case studies a lot in psychology. A case study is an in-depth look at a single individual used when the unique aspects of an individual's life cannot be duplicated. Usually in clinical psychology, one of the other classes that I teach is abnormal psychology. And in abnormal psychology, when we study anxiety disorders, OCD, PTSD, major depression, schizophrenia, we will read case studies of people who suffer from those disorders to see what it is like for them on a day-to-day basis and what are the unique aspects of their experience with that disorder. One of the biggest benefits, we can get a lot of ideas and detailed descriptions of what it's like for that person. However, there's a big danger that we have to worry about. You cannot overgeneralize from one case to another. You might have 2 people side by side who both have been diagnosed with major depression, but that major depression can look very different in 2 different people. Many of you might know somebody, let's say, who suffers from depression or maybe even anxiety, and the anxiety manifests itself differently in one person as compared to another person. So you never can overgeneralize from one case study to the next. When we get to the end of the semester and we talk about psychological disorders, which is my favorite chapter, we'll be looking at a lot of different super interesting case studies as well. Okay, next we move into correlational research. Correlational research is very different and used in a different way than observational research. The basic purpose of correlational research is to detect naturally occurring relationships and to assess how well one variable predicts another. The most important thing that you have to remember about correlational research is there's no attempt to alter any variables. We're looking at naturally occurring relationships, and we're not looking at cause and effect. There's no causation between these. These things are already happening in our environment, and we're just looking at how one variable predicts another. Remember, no cause and effect. Our definition for a correlation is a relationship or an association between variables. And in science, the science of psychology, we look at this in our research through what's called a correlation coefficient. Correlation coefficient is the mathematical expression or statistical measure of that relationship. Luckily for us in Psych 150, we do not have to worry about calculating a correlation coefficient, but you will probably see them in some of the research that we look at this semester, so it's important that you know what it is. That mathematical expression will always range between -1 and 1 on a number line. You will never see a correlation coefficient that is above 1. You will never see a correlation coefficient that is below -1. It will always range between -1 and 1. In a correlation, this correlation coefficient is always represented by the small letter r. So if you're looking at a research experiment in a journal or something and you see that their results contain a small letter r, you know that it is a correlational research. There are two really important things that we look at with that number. Number one is the strength of the relationship, and number two is the direction of that relationship, and we're going to talk about both of those. When we talk about the strength of the relationship, it is what is the quantitative amount of that correlation coefficient. Again, it has to range between -1 and 1. Can't be below -1, can't be above +1, right? The closer that relationship is to 0, the weaker the relationship. I'll say that again. The closer that correlation coefficient is to 0, the weaker it is. The closer that number is to 1 or -1, the stronger it is. For example, if we have a perfect positive correlation, it would be either 1 or very close to 1, maybe 0.98. If we have a very weak relationship, it would be very close to 0, like 0.05, right? So we're looking at the strength of that relationship. We also want to look at the direction of that relationship, meaning that it's either positive or negative. So we already talked about that strength. Let's talk a little bit about direction. When I say that correlations differ in direction, meaning that they're either positive or negative, please do not think of positive and negative in the sense that it's good or bad. Positive here means something completely different, and negative means something completely different. It has nothing to do with good or bad. If we say that a correlation is positive, it means that we're talking about a direct relationship. Both variables either increase or decrease together, and that's a relationship between 0 and 1. Again, closer to 0, the weaker it is. Closer to 1, +1, the stronger it is. But a positive correlation, both of those variables run together. For example, as the number of hours you study increases, I would expect your test score to increase, right? As one goes up, the other goes up. As one goes down, the other goes down. They always travel together, okay? A negative correlation indicates what we call an inverse relationship, which means that they're the opposite. As one goes up, the other goes down. As one goes down, the other goes up. And this is a number between 0 and -1. So again, the closer to 0, the weaker negative correlation. The closer to -1, the stronger the negative correlation. I might say, as the number of, let's say everybody in our class goes out for dinner and drinks the night before an exam. And I notice that people who usually do really well failed the exam. And I say, man, you guys usually do really good. What happened? And you say, well, we had a contest to see who could take the most tequila shots. We could look at the negative correlation then. As the number of tequila shots increased, what do you think I would expect to happen to their test scores? Their test scores would probably decrease. As the number of tequila shots increase, the test scores decrease, right? So it's inverse, meaning that they travel in opposite directions, and that's going to be between 0 and -1. A zero correlation means that there is no relationship. They have no relationship at all between those variables. For example, if I said I want to look at the relationship between people who chew gum while taking their test and test scores, I probably will find some people who chew gum and do really well, and some people who chew gum and fail. Some people might not chew gum and do really well, and some people might not chew gum and fail. So there's no relationship at all between those. And with that, our correlation coefficient is 0. Again, the most important thing you need to remember about correlation does not prove causation. These are naturally occurring variables. We're just looking at the relationship between them. Our next type of research is experimental research. So leading up to this, we've talked about descriptive research, correlational research, but what most people think of as research is actually experimental research. Experimental research. We use methods that test causal hypotheses by manipulating the independent variables and measuring the effects on dependent variables. In this type of research, what we're doing is exploring cause and effect. Now, we said in correlational research, it absolutely is not cause and effect, but in experimental research, we are looking at cause and effect. If you look at that definition, we're talking about manipulation, we're talking about independent variables and dependent variables. If you've never had this before, it can tend to be a little bit confusing. If you find that to be the case, please come to the office hours this week. I will definitely go over this in much more detail. I can give you a lot more examples if you need help in understanding experimental research, because for some students it gets a little bit twisted and a little bit difficult to understand. In order to do experimental research, it's really important that we understand exactly what we're studying. Part of that is creating what we call an operational definition. With the operational definition, we qualify or describe and quantify or measure variables so that they can be understood objectively. So we have to know what exactly we're doing it. We talked a little bit about replication before. If people want to replicate or copy our research, we have to be very specific in how we describe the different variables of our experiment and how we quantify or measure the changes in those variables so that we can tell if our hypothesis is correct or if it's not. With experimental research, we have to talk about who is our population going to be. We look at a population as the entire group that you want to know about. Let's say, for example, we want to do an experiment on aggression in teenage boys. My theory maybe is that I notice that my son, after playing certain video games, is more aggressive towards his sister. Okay, so that's my whole theory, that certain video games make teenage boys more aggressive. Well, I certainly can't measure that. I need to make it more specific. So my hypothesis is that boys between the ages of 15 and 17, after playing video games become more aggressive. Okay, I have to operationally define what I mean by aggression. Is it hitting somebody? Is it tripping somebody? Is it smacking somebody across the head? Whatever. And I have to operationally define video games. Is it Animal Crossing? Is it Call of Duty? Is it NHL 2020? Whatever it is, I have to be very specific about the operational definition to those variables. So if I'm saying boys between the ages of 15 and 17 who play 2 hours of Call of Duty every single day, I'm hypothesizing that their aggression as displayed by hitting or tripping will increase, okay? My population is boys between the ages of 15 and 17. I can't possibly test every single boy between the ages of 15 and 17 in the United States. So my population is the group I want to know about. It's important that I take a random sample of that. A random sample is a sample that fairly represents the population by allowing each member of the population an equal chance of being included. Now, if I say, well, if I'm going to test boys between the ages of 15 and 17, and my office downtown Raleigh is right next to the Juvenile Detention Center, would be a good idea for me to use a random sample of the boys from the Juvenile Detention Center as my experiment? Probably not, right? Because if they're in the Juvenile Detention Center, there's a good chance that they already are showing more aggressive tendencies than the general population. So I want to make sure that it's a representative sample is our random sample. We also want to make sure that there's random assignment. We're going to talk about groups in just a second to make sure that everybody has an equal chance of being in every type of group in our experiment. Random assignment makes groups equal, and we want to make sure that everybody has an equal chance of being assigned to any level of the independent variable. So let's talk a little bit about what that means. Control group and the experimental group. So the control group is that comparison group. They're going to be the group of 50 drivers who do not get the whiskey. The experimental group is the group that gets a shot of whiskey every time they go through the driving course, right? Through both of them, we will measure the dependent variable, right? The variable that's affected by the manipulation of the independent variable. What's being manipulated? The independent variable, which is alcohol. What are we going to measure? Their driving ability. Here's just a chart that goes through all of these elements of the experimental methods, advantages, disadvantages. Again, you have your independent variable is what's being manipulated. In the example I gave, whether or not somebody's going to drink the alcohol. The researcher randomly assigns subjects to the control group or the experimental group. In our example, we had 100 students divided equally into 50 each. 50 would go in the control group who do not receive the alcohol. 50 would go into the experimental group who receive the alcohol. And then number 3, we measure the driving ability, which is our dependent variable. We analyze the results and then we come up with our conclusion. I know some of this experimental research method information is kind of confusing. Again, if you have trouble understanding after this PowerPoint and reading your textbook, please come to office hours this week. I have some examples to set up. You have homework this week that will be due that exactly deals with experimental research. So make sure that you can understand it so that you can effectively complete your homework. And if you come to the office hours this week, we can work on the homework together if you need to do that. So that is our research methods of Chapter 1.